sessions. I know you had great alternatives and you decided to stick with it. My name is Julian Ortiz. I'm a solutions architect at Oracle. What I'm going to share with you today is our own experience to migrate an Oracle product, a Java monolith, to a microservices application under service architecture. So I'm going to ask the audience if anybody is in this same path to migrate. Okay. So I'm going to set the stage agenda, what I'm going to discuss today. So we start with, I'm going to dive into the monolith application, goals and desires. Second, I'm going to share how did we get from point A to point B. And number three is along the way, we face interesting challenges and that require unique solutions. So I'm going to share those a little bit in detail. And lastly, a summary. So when I start by saying a monolithic application, what we're talking about an Oracle product, it's established product, and it's go by the name of order and service management. It's part of the suite concept to cache to care. And it may not be clear what is the concept to cache to care, but if I break it down into sections, is concept is the stage where involves creation of new services and offerings, and cache is where you group the order management and the billing and revenue management. And cache is basically focusing on customer service and customer support. Under that concept, there's a couple of tools there, a couple of products. And this one is basically designed to streamline the billing and the entire customer lifecycle and its delivery, its ongoing conversations with the customer and take care of those customers. So imagine here, let's say, to bring an example close to home, you have a service provider, an internet service provider, right? And they create an offer where they're going to build together, they're going to bundle together internet plus a TV service, right? So they create the offer and they basically start by you accepting the offer, and they capture that order in the CRM order capture system. We then integrate with, let's assume that we are going to ship the equipment to your home, and we have to set up a billing around the equipment and the service. So the next step is to use the billing BRM, billing residential on the right side. And this basically takes care of the invoices. And then it takes care, the other step in that order is taking the equipment or retrieving the equipment from the warehouse, putting an order, a shipping order with a shipping partner, and send it to your home. And lastly is you get the equipment and they dispatch somebody to your home to make sure that you got the internet or the service that you acquire. And finally, using one of the activation systems, they activate the service. So it's basically order, fulfillment, and delivery of the services. This is meant for telcos and large enterprises. And this started being developed a long time ago. So it started as a Java EE application, and now is what we call the monolithic application. So how it is traditionally deployed. It is a Java application that is deployed on a WebLogic application server, which is a Java EE compliant application server. And it is the big area there, or rectangle area, domain, is nothing more than a logical grouping of JVMs, virtual machines that are the ones that eventually run your application. This could be distributed into physical or virtual machines, and those physical virtual machines get deployed on premise. Now, this application, it has, as we saw in the previous slide, it has different entry points. One key entry point is a JMS. We use messaging where the product is heavy on JMS usage. Then HTTP and HTTP access for web applications. It has shared storage. It requires shared storage, database, and LDAP server. So this is, again, traditionally deployed monolithic on-premise. If you look a little bit deeper on the models that it has, on the different integration layers that it has, it integrates with network operation center, support operation center, customer care, product manager, CRM, top there, not very clear, but top there. And a lot of modules inside the big gray area center pane is what comprise this resource manager application. Sorry, service management application. So as you can see, rebuilding and creating new functionality to the product, it becomes very complex because it's now part of a big group of mixed together modules that make it hard to update, test again, and that has to happen with every new release. Now, bug fixing is another complex, is one single repository where everybody has to fix and reuse the code again. So this is, Monolith makes it complicated because of these two reasons, working on a single monolith. So the directive was, let's evolve the existing monolith application to be hosted and hostable in the cloud. And the product team wanted, in an agile fashion, add some functionality to the service. So they wanted to include new functionality to the service, and also under a service architecture, become a cloud native conformant application. And well, this is pretty normal stuff, right? Everybody is doing it. Every company, whether or not it started already, is thinking about moving in that direction. The real difference that we want to share here is that this is a product that is already deployed around the world, different customers. So we have to take care of that base that is already running the product. So we have to throw in some real constraints. First is we have to optimize investment. We don't have an unlimited team that can come in and deploy everything that we want. No, we have a fixed number of developers. So we have to know what to invest in and what should be the moment that we should invest on. Then is maintain value. OSM today should remain operational, or I shouldn't say operational, should keep the same functionality, because as I said, we have already customers running it. We have to maintain. We cannot come in and say, hey, I'm ripping off everything and start fresh. Then the last thing is minimize risk and disruption. Imagine that we have a big telco, one that processes millions of orders and transactions per day. And I come in and tell them, hey, we're gonna take away everything and deploy a new whole system, completely new, that does different functionalities. Most likely, I guarantee you, they're gonna be like, no, thank you. I don't wanna risk my operation being affected by something new, especially how critical it is in the enterprise. So this is an established product. So we have to define a migration pathway that is not disruptive to end customers. In that sense, the product team defined some objectives. First, we were going to keep the same traditional cluster application. That had to be remain for those on-premise customers that already have the product deployed. Then we wanted to be cloud native ready. We wanted to make use or improve the agility when how we deployed and delivered, and also reuse and rely on the elasticity that a um, cloud native architecture will give us. And then the other one was just to select a modern microservice tech stack, something that will let us build new functions on microservices. Once we establish that, grow the functionality. We wanted to add new functions, enhance the product, but once we cover the first three stages of our plan. And last, now that we feel like we have a robust integration with the system in different components, we want to work on different advanced deployments like blue-green or sharding or countering deployments. Now, to come to this, we decided, though the product team decided that to grow functionality, we were going to use the strangler pattern approach. We were going to take pieces, eventually move it around, and that way we will have services that complement the architecture. Right now, we're end of 24, beginning of 25, growing functionality and working on the advanced deployments. So OSM is today is in two journeys. One is cloud native journey, and the other one is the microservices journey, right? And we would like to remain on-premise traditional, but we also want the next step to be the on-premise cloud. So move the application and make use of DevOps methodologies in the application, which reduces the time to deploy. And lastly is this journey to a cloud. So make sure that we can have the same common code base be deployed as a software as a service, which eventually automate the provisioning on different clouds. So phase one, how do we? The team started working on Kubernetes support with the following restrictions, right? We need to the application OSM needs to be run as it is. No, with new applications, but no changes to those applications. So we took WebLogic domain, that is, I showed you earlier how you deploy traditionally, and we use a Kubernetes toolkit that will allow us to take that application server and put it into containerized images. That way, once we release them, customers were able to pull those images down to their Kubernetes cluster, and we were able to see immediate benefits. Provisioning, it was quicker. We were able to update binaries and release them quicker. Scaling based on metrics that Kubernetes were able to give us, and take better actions based on what we were seeing. Now, definitely what it comes when you deploy an application or some container into Kubernetes is you get high availability, depending on the configuration, but you immediately get high availability. And definitely the one key asset is portability across on-premise clouds or public clouds, which is one of the goals that we wanted to do. So the Kubernetes toolkit, this is just what different tools that comes with this toolkit. We use the image generation tool, one tool that is just meant to extract the logs from the application server and ship it to different log repository. And then all this via a WebLogic operator that knows and understands how to deploy the WebLogic application. This is not related to OSM, but to the application per se. So then, now that we had it on phase one completed, we had it on Kubernetes, we end up having this sort of mix of OSM the monolithic application in a container with just the minimum set of microservices, login and the operator and some div installers and characteristic deployer. But we wanted to do the phase two, that then we were ready to go with phase two. Phase two is just building those microservices, new functions around it. But with it, we face definitely challenges to go along this phase two. Developer productivity. The developer team felt the hit. They were used to develop this monolithic. They already have their cadence. By switching to microservices, it took time for them to switch to that methodology, that mentality of writing microservices. Then once they were above that learning curve, the integration is very critical, because as I shared at the beginning of the session, the product integrates with tons of systems within telcos, billing, CRM, whatnot. And we were adding a layer in between the external systems and OSM, or the monolithic application, which was this microservices built around. So we needed to be sure that that integration didn't affect what we already have, right? And then with it, of course, you have, you want to provide your application a flexible configuration that it can be deployed based on the environments that different customers are gonna find. We don't have a really homogeneous customer base, so we had to provide this flexibility for them to deploy it in different environments. And this really was a challenge for us to be able to provide a flexible configuration. Now, we started to focus on technology. We wanted to pick the microservices, the framework that will help us build our microservices. So we wanted to be Java, continue with Java, OSM is Java. We wanted to support databases, be cloud ready, and we wanted to play along with CNCF. We want to leverage the projects that they have, so be a good CNCF citizen, like using projects like gRPC, OpenTelemetry, Prometheus, those kind of projects that we all benefit from it when we start integrating in the environment. And last but not least is Jakarta, EE, and MicroProfile. These are the key driver for us. So some of you may know what is MicroProfile. Some of you may not know what it is, but it's open source, vendor, collaborative effort that will basically a technical specification that will allow you to build microservices quickly. And the important piece here is that it shortens the curve from working in normal day-to-day Java EE to microservices. That's in my opinion, that's what augments developer productivity and gives you this specification for other frameworks to apply. But that's, for me, the goal of MicroProfile. And of course, it just helps you with portability, so you're not locked in. You can ditch this vendor and move to another one if the other one suits you better. So now that we share what is MicroProfile, let's continue on our search for that specific framework. We want it to be 100% open source. We wanted for it to support or to be cloud native ready and support Kubernetes. And then, as I said, is native support for MicroProfile in Jakarta. That's kind of how we started that search. And that it has a philosophy where it goes with simplicity when you start writing code, transparency, something that is fun to use and that is easily maintainable. So that's another key area that we were looking for. And finally, is we have so many integration points that with the current load that we see on customers and adding new microservices around it, it could impact your performance. It could impact what you deploy, the load that we have, the load that the system could have. So we wanted a microservice that was light and fast, that didn't require an application server, because what we already had in OSM is already an application server with logic. So we wanted this microservice to not have to require an app server. And we found Helidon. So Helidon, if you want to check more about Helidon, feel free to go to helidon.io. But I'm going to share a little bit more about here, high level. So Helidon comes in two flavors, SE, Standard Edition, and Micro Profile. It just basically reflect two different styles of developing. That's about it. Helidon SE is the core of Helidon. So it's very light footprint. You write your applications in a plain Java code with an imperative style. That's it. It's easy to understand. Now, with Micro Profile, this is an extension of SE. So you have the key features, key APIs, Jakarta APIs, conforming Micro Profile APIs, which again, this is something that we were looking for. And you develop your application using a declarative style. You use CDIs or dependency injections, annotation, JAX-RS to build your application or microservices. So kind of to put it in a simple term is, with SE, you get an engine, but you have to build your car, right? When you're talking about MP, you get the same engine, you get the car, and you get to tinker with the car, right? So it's two flavors, but it's the same thing. It's under the covers is SE, and the other one is the extension of the other, the first one. So the only thing that matters is which approach you want to use depending on your development style. So upon looking and checking further what was supported by Helidon, we looked at the Jakarta specification, right? And the micro profile specification. That we know it was compliant. And then we started to looking at the modules that it support, right? So we use quite a bit the protocols modules, logging, messaging, persistent, and fault tolerance. Those are the key modules that we were looking for. So as you can see, it has built atop. This is a layer approach, cake layer approach that you can pick and choose what you want. So another reason, how do you build and run? This is another feature that comes with Helidon. You can pick your build format, whatever build format you want. You can build based on our criteria, startup time, build time, whatever it is that you are looking for. And then the runtime platform. It can pretty much run anywhere, bare metal, VM, containers, and Kubernetes. And then at the end, you run it in, you could run it again in on-premise, cloud, or edge. So this gave us the flexibility to move the application whatever we wanted to, in private clouds or public clouds. Now, that was Helidon. But when we started adopting the framework, we noticed that we started with 2 and 3. We noticed that Helidon was built on top of Netty. Netty is an open source framework to develop network applications. And Netty relies a lot in platform threads. Platform threads and management of platform threads is not comparable to different stacks like Golang. They have a high memory overhead compared to other tech stacks, and the concurrent upper bound is in the thousands, as opposed to other that is hundreds of thousands. So that is something that we were like concerned a little bit, and to avoid this, and we started working on or to avoid this platform threads and limitation on the memory and the concurrency. You have to start playing with Java, start developing in a synchronous mode, or basically a reactive approach, right? And then you start going into this reactive Java Inferno. You have to asynchronous coding, then it goes complex, poor debugging, and then everything becomes complex, really complex to do. So for those Star Wars fans, as General Akbar said, reactive is a trap. But the Empire strike back again, and Helidon 4 came out. Helidon 4, which is something that we like about this process, is that it uptake the most recent JDK releases features really quickly. Now this is completely rebuilt and is built on Java virtual threads that it's faster to spin, it uses less resources, and in our case, less resources for our customers, big telcos and other big corporations that they handle millions of orders per day. It means at the end of the day, cost benefits, improvement in cost. So JDK Helidon 4, it's what we are looking forward in every framework, every microservice that we build. It has a low memory overhead compared to others, and the concurrency, the upper bound, is in the millions. So we were pretty much sold, and we wanted to test this with our internal applications, and we can see, we compare it with previous versions and with some other framework that people know about. So in these graphs, if you can see, less is better. It doesn't mean that the longer it goes is better. It's the opposite. So first response time is 253 milliseconds compared to other ones. Same thing for memory usage, less, and for disk space usage is less. So we kept, defining factors for us. And it should be the same for every framework that you're gonna pick in that journey to build microservices. You have to take care into the functionality that it gives you and how performant it is, so that your microservices that you're building is not gonna affect the approach of adding them on top of your monolithic application. Just to share internal test results of using Helidon, we were able to, with a similar latency, we were able to get 63% less platform thread usage and 30% less CPU utilization that compared to the previous version. So that definitely, as I've been saying, is small pieces make it a perfect framework for us to use. But going back to our original mission is, how do we put these pieces together? We have in the center, we have the WebLogic server, and we need those microservices to be able to integrate with the core common code base. We define that it should be using protocols that are standard to WebLogic and that Helidon will support. So I'm gonna share some challenges that we face around JMS, because OSM relies heavily on messaging system. And sorry if I go back a little bit here, is you may be asking, well, what is the purpose of doing this? This is not, as one of our internal directors said, this is not a beauty contest. This is not just throwing stuff because we wanted to make it a microservice compliant. Is that when you start working with a monolithic application and now you want to distribute it around the world in a cloud environment, then you have to put pieces in different data centers. That with a monolithic application is very complex. But if you do microservices and use with the framework we're using, Helidon, then it made it easier to go that way. So that we define how we wanted to integrate. Now, how do we augment the monolith? How do we add new functionality to it? Again, our first restriction is no more functionality was gonna be added to the monolith itself. It's gonna be live as is. But it will, and it will continue to be deployed as a traditional because our main factor was the customers that we already have on production, but they were able to use new functionality that will come as part of the new microservices. And all microservices were going to suppose be at rest. That's our one main goal. The second thing is, when you add this number of integrations and moving parts, fault tolerance is going to become key. And I'm going to share more details of how do we handle a specific scenario with fault tolerance and this framework. But we have to add fault tolerance because definitely everything needs to be resilient. And then metrics. Metrics is another key factor. We want to understand what happens inside each microservice. We didn't want to know only the boundaries, what happened at the boundaries. We wanted to understand what happens inside the microservices. So we needed to enhance metrics, collecting and analyzing to be able to understand what's happening. And messaging, of course, we have JMS, but we wanted to enhance that experience and solve a couple of bottlenecks that we were seeing. And we use Kafka to integrate with external systems. So picture, it would something look like this, right? It's just standard, pretty normal things, right? You build services around it. So fault tolerance. I'm going to stop here a little bit and talk a little bit about fault tolerance, mainly because we understand, or some of you, or maybe all of you understand, what are the implications of having an application that is fault tolerant. But really, at the end of the day, what it is, what's fault tolerance? And it's nothing more than you applying strategies to guide the execution of your code, and based on the result, take actions. There's definitely commonly used popular patterns or concepts like timeout, retry, bulkhead, circuit breakers, and you can use a mix and match of those on those popular concepts. But what matters is, how do you rely on the framework that you're using to be able to integrate it in your application? MicroProfile let us use Helidon let us use in the MicroProfile version a set of patterns to use, and at the SE level also a similar approach, some patterns that we can definitely integrate as part of the code. Now, what we're looking is to push that functionality on the framework itself, which is going to bring us definitely a lot of benefit. It simplifies the code. So now your code is less error handling and more just the business logic. And then you have a standard approach to deal with any integration that you're going to have as part of this application. And of course, with handling errors and resiliency is definitely a key. In detail, one example applied to OSM and its integration pieces. It has all orders that come in are going to be placed in a JMS queue. So retrieving those messages and send it to external systems. Remember, we have shipping in-house or shipping to a partner, so we have to, the product has to contact that external system, pull that order and send it, create an order to the external system. And in that process, you're going to face two types of errors. Persistent errors, where something happened and you reach your threshold, and that's it. You cannot do anything. You finally decide nothing I can do. But the complicated ones are those transient faults, those that can happen randomly. In case of OCM, if I'm putting an order for a service, let's talk about the example I gave at the beginning, where you have your internet provider. So you want or your phone service provider. You want to place the orders and its subsequent task in the order they were received. Otherwise, you probably start doing processing the billing system before having the customer in. So we needed to preserve the ordering. And transient errors affect that ordering quite a bit. You started with first task, it failed, and then you try to go to the second one, but you have a dependency already. And your messages that you're pulling out from the messaging system has to follow that, has to keep that order. So we use a mix of retry, timeout, and bulkhead. The key here is bulkhead. Bulkhead help us, give us the benefit of compartmentalize orders so that an order and its subsequent task or subtasks are placed in this box, right? Bulkhead, in this compartment. You can have as many of those boxes to be run in parallel so that in case there's a transient error with an order, not every order that is coming behind you is affected. They can be processed in parallel, and they have to remain wary about the order ID they are running. So that is the box that everything that is inside that box will be processed and will only be accepted if all the tasks inside it are processed. But that was one benefit. But the other benefit is we have to talk to external systems, right? And those external systems, we don't know how resilient or what is the load that they can stand. By using bulkhead, we were able to throttle that the number of messages that were sent to that external system. The reason is if we approach it as a bulkhead fault tolerance mechanism, then bulkhead controls the number of calls to a specific method. The framework does that control. I only tell them how many concurrency requests I'm gonna approve, and then if I need to do either just roll back everything or keep adding them to a queue. We followed the second approach, which is create a queue. 500 threads are gonna be put in there before we decided everything was not salvageable, and then we just needed to revert back. But going back to how do we solve that concurrency is now only 5 threads could read a message from the JMS server and send it to the external system. So no more than 5 requests could be reached to the other end. That way, we control the order by grouping by order, and the other one is just to control the number of messages that we could send to the system, external system. Now, power, we were thinking about using MP for almost everything. But this is one of the reasons you have SE and MP that you can mix together in your application. We needed a configuration that was flexible because not every customer has the same capacity in their system. So we need a way to configure in a way that it was flexible. And the reason is that MP or microprofile literals, they're not computed at runtime. So we decided to use SE and code that configuration. So MP here is the way you annotate in your code, and you get, let's say, value of 5 is just 5 concurrent threads, and the number of threads are gonna be put on hold on the waiting queue. Now, we decided, hey, well, with our configuration, our configuration file is gonna have the cluster size in it. So we are gonna understand how big is the external system, calculate the concurrency limit, and now we can manually create the bulkhead pattern, not create the bulkhead pattern. We use the bulkhead pattern that is provided by the framework to be able to control or throttle the request and mechanism to reach the other end. Definitely, it solved lots of issues that we were having when we were putting a lot of pressure on systems that we were not realizing what was the problem. So at the end of this journey, we have been growing services, and we are pretty much in the end of 2024 and beginning 2025. We had augmented we keep fleshing out functionality into new services, always keeping the same approach. OSM, which is the core common code base, and all those services around it, has led us to this cloud native journey that we are today. I know a lot of you are doing something similar, and some you may say that is not the correct time, and some may say that is you may already working at it. This is what we decided to go in our approach. So in interest of time, we started with a problem. We wanted to modernize our Oracle product, giving it agility and flexibility. And we wanted to have two ways to deploy the product, on-prem and on cloud. We had to have real life constraints because of the nature of the product, because it was an established product. So optimize investment, maintain value, and minimize risk and disruption. And the solution that I shared is we containerize the application server, move it to Kubernetes, and then via Helidon microservices or microservices built on top of Helidon framework, we were able to increase developer productivity and flexibility to the application. Key technologies that we use was a Kubernetes toolkit, and of course, Helidon, which is the framework we decided to use. If you want to read more about what is the Helidon and what it has uptake from the Java community, just here's an article, Java Trend Report in 2024. So with this, thank you very much for your time. You can check Helidon in social media, and appreciate your time today. So if you have any questions, let me just fire. So thank you very much for attending this session. I appreciate you joining.